Alright, today we're going to talk about how to solve systems of linear equations. That's what we've been talking about, right? What was our first method of solving systems of linear equation?
Graphing.
Yeah, by graphing, because when you have systems of linear equation, that means you have more than one line when you graph, right? So when we have two lines, where the two lines intersect, that's your solution. You guys remember? So we had to graph and so forth. We're going to learn how to solve systems of linear equation in a different way. It's called substitution method. The name kind of gives it away. Guess what we're going to do? We're going to substitute. And in this method, guess what? The graphing, you don't have to graph. So instead of graphing, we could actually figure out the solution of the systems of linear equation. Now, as you did your homework last night, there were some limitation in terms of graphing. What were some of the things you found as you were figuring out the solution of systems of linear equation when you by graphing? What were some limitations that you kind of saw? Anybody? Yes?
Sometimes they didn't.
Yeah, sometimes they don't, when they intersect, the intersection is not a nice point, like 2, 3. You know what I mean? It was some maybe fraction or maybe decimals. Sometimes you couldn't really tell, right, exactly what those intersections were. That was one of the limitations. What were some other limitations that you sort of realized? Graphing a line, it does take a little bit longer than the method that I'm about to show you. Yes? Yes? Another?
The intersection might be off the graph.
Yes, the intersection might be off of your graph, right? So what if your intersection was like 3,000, 7 million or something? You know, you're not going to be able to. You're not going to be able to, graph this really easily. So you're right. So because of those limitations, sometimes you don't know where the where the exact order pair is, because when they don't really intersection isn't not on that nice grid, or if it's off of your graph, we don't know how to do. The graphing method isn't really good. But graphing method is kind of nice because you can visually see where they intersect. You see what I mean? So it's a nice way to really understand what's going on. So that's why we have this substitution method. Okay, this substitution method again does not involve any graphing. Okay, we're going to do this algebraically. Okay, so let me show you how to do this. Here we go. Here's our first equation, systems of equation. It says solve using substitution method. And I'm going to show you what that is. It's actually, just like the name suggests, you're going to substitute. So we have two equations. 2x plus y equals to 9. X plus 4y equals to 1. So let me show you what to do. Your first step is, since we have two equations, you choose one of the equation and solve for one of the variable. That's your first step. So we're going to have to solve for one of the variables. Look at the first equation. I could choose the second one too, but I'm going to choose my first equation because look at this first equation, 2x plus y equals to 9. Which variable should I solve for? I could either solve for x or y. You have a choice. Which one would you like to solve for? Y. Why not x? Very good. I would solve for y.
Oh.
Aaron?
You put x as a 0 and then that would be y equals 9.
No. You're solving for one of the variable. So you look at the first equation. I'm going to solve for y. In other words, I want to get the y by itself. Why not get...
Y is already by itself.
Yeah, in other words, if I were to solve for x, you get some fractions and stuff. If you could avoid it, why not make it as simple as possible? So that's what I'm going to do. I'm going to solve for y. So how do I get the y by itself? What do you do with the first equation? Yes, Carolyn?
Subtract 2x on both sides.
Yeah, subtract 2x on both sides. Exactly. And we just get simply y is equal to negative. So I'm going to write it this way, in like kind of like a slope-intercept form. Y equals to 2x negative 2x plus 9. Very good. And just like the name suggests, guess what? Now that I've used my first equation, I'm going to now substitute. You see where the name comes from? I'm going to substitute what? Y. What's y equals to? Negative 2x plus. I'm going to substitute that in place of y there. Does that make sense? Because it's saying y is equal to negative 2x plus 9. Why not you just substitute that into where it says y on the right side. When you do this, nice thing happens. By the way, whenever you substitute, what should you use? Parentheses. Exactly right. So when you do this, this is the third equation you get. When you substitute, use parentheses, and when you do this, okay, we get x, as you can see, x plus 4 times, I use the parentheses, negative 2x plus 9, that's what we said from the first equation, right? Equals to 1. And I like this third equation because, go ahead and everybody write it down. What do you think we like this third equation? We're basically substituting in the first equation to the second one, right?
I got
Why do we like this one? Go ahead, as you write this down, you should realize why we like this one. Go ahead, everybody think about it. So how come I like this third equation? Anybody see why I like this third equation now after I substitute this? What do we do all this for? Let me give you a hint. How many variables did each of these equations have? 2. Now, how many variables do you have? 1. And do you know how to solve an equation with 1 variable? Yeah. We've been doing this many times, right? We've done this many times. Like an intro, right? So we distribute 4. When you distribute 4, you simply get an equation, right? You get an equation with 1 variable you know how to solve, don't you? Right? Do you see how I got negative 8x plus 36? Because I need to distribute this 4. Can you solve for x now? Yes, you should all know how to do this. Go ahead, everybody. So yeah, I like this. So on the third equation, if you did this correctly, you should get one equation with one unknown, one variable, right? And you know how to solve that, right? Okay, go ahead and finish it up. See what you get. So a lot of you got x equals to 5 because you get negative 7x plus 36 equals to 1, right? When you combine positive x plus negative 8x, don't you get negative 7x? And then of course you subtract 36 both sides, right? And then you get 35, negative 35. Divide both sides by 7, x equals to 5. Now, am I done?
No.
Why not? I got the answer. I got x equals to 5. Bella, how come I'm not done here?
Wait, that's the answer I got.
Right, so how come I'm not done then? Okay, so let me ask you, Bella. You know how we had two linear equations? From last time, by graphing method, we knew when the two lines, what is the solution of a systems of linear equation? That's when the two lines, where the two lines intersect. And when the two lines intersect, what did your solution look like? Did it look like a number, or was it an order pair? It was an order pair. Look what we have now. You have to find the y exactly. So we only know the x coordinate of this order pair. We don't know the y coordinate. Remember last time when the two lines intersect, the solution is an order pair. So how am I going to find this y coordinate of this order pair? Any idea? Angel? Yeah, you plug into the either first one or the second equation. How come it doesn't matter? Because it has to be a solution for both. Remember? Where the two lines intersect, right? That order pair is the solution for both of these equations, right? So, this is what I wrote down. You don't have to write this. This is only the x coordinate of the intersection of the two lines, right? So how do I find the y coordinate? You plug into the one of the first. You could either plug into the first equation or the second one, or what's even better? Since we know you don't have to plug into both. Since we know the x, you plug into both at the end when you have the answer to check the answer to see if you got it right. So now if I have the x equals to 5, I could either plug into my first original equation or the second one, or since I'm looking for y, which one should I plug into? Anybody see what we have? Well, yeah, the first one, but look, when we change first one to y equals something, can't I just plug into this? Because are we not just looking for y anyway? So why not plug in x to where y when we solve for y? Wouldn't they give us just the y? It doesn't matter. You could just plug into the original ones, right? But now that we solve for y already, why not just plug into this equivalent equation? Does that make sense? Which came from the first equation. So go ahead and plug it in. It doesn't matter. Like I said, you can plug into any of the original one or the one we solve for y. Go ahead, everybody, do that, and tell me what the coordinate of the y is. Okay. So doesn't this come from my first equation? Y equals to negative 2x plus 9. Okay, why did I choose this equation? Because what are we looking for? We're looking for y. So let's plug in 5. How many people got the answer? What do you get? -1. Yeah, how many people got -1 is the answer? Okay, so how do we write down our solution then? Michael?
Y equals -1 and x equals 5.
But is that how we write our solution? When the two lines intersect, Michael, what does the solution look like? Yeah, you could say x equals to 5, y equals -1, but what's another way of writing that? Yeah, it's an order pair. So what would you write?
So you put 5, -1.
Yeah, 5, comma, -1. Because we know that when the two lines intersect, the solution is an order pair. I mean, you could write them separately like that, but why not write it as an order pair? Right? Isn't that what we learned last time? Is that okay? Does that make sense? All right, let's do a couple more. Here we go. So take a look at example 2. We're going to use substitution method to solve the systems of a linear equation. I have x minus 2y equals to y, 2x minus 5y equals to 4. So we're going to choose one of the equation and solve for one variable. Claire, which one would you like to choose? Which one? First equation or the second equation to solve for one?
I did the first.
Yeah, I will do the first. Why?
Because it's easier.
Yeah, why is it easier?
Because we already solved for y.
Oh, it says y is equal to this, right? But have we really solved for y on this?
No, I mean never mind.
Okay, what would you do? What would you do on the first one to solve? Which one would you like to solve for?
Okay, I'll do number 2.
Oh, really?
Yeah.
No, you.
I don't know. I don't know what to do.
Okay, so let me show you. First step is to choose one of the equations to solve for one of the variable, x or y. Okay.
Okay.
So you have choice to choose. You could either choose equation first one or the second equation. Which one is easier to solve for one of the variable?
Number 1.
Yeah, because the second one, if you want to solve for x, you have to divide both sides by 2. If you solve for y, you gotta divide both sides by -5 and so forth. So you get fractions. Why not solve for, which variable would you like to solve for in the first equation? X or y?
Y.
You want to solve for y?
No, x.
Yeah, you could solve for y, but then you got the other y over here. So you want to solve for x. Isn't it easier to get the x by itself? Because this term has y in it. You got to gather these anyway, right? So if you solve for x and there's 1 in front of x. So what would you do to solve for x?
I would add 2y to both sides.
Exactly. You would add 2y to both sides. And here, you just get x equals to 3y nicely. Then, we're going to do what? We're going to plug it in. We're going to use substitution method now to plug it in. So we're going to plug in place of x, because it says x equals to 3y. What are you going to plug in place of x? 3y. So Royce, tell me what's right.
2 times 3y
Mm-hmm.
minus 5y.
Exactly. And of course, you got to use parentheses. And look at my third equation. How many variables do I have in the third equation? 1. And do we know how to solve for that variable? Go ahead, everybody try. I'll wait. And once you get that, you know how to find the other variable. You know how to find the other, right? Variable, which is x. You know how to find x, don't you? Once you find y, right? Go ahead, everybody try. I'll wait. Okay. So, how about? Let's see. Chuck, tell me what to do here.
So, when you get x equals 3y, you plug it into the second one,
Right.
and then you solve.
Yeah, what did you get when you solve?
So it's 6y minus 5y equals 4.
Good. And then after that,
It's y equals 4.
exactly.
And then you plug that in.
Yes, very good. So we have the y coordinate. We need to find the x coordinate. Now this time I just chose one of the original equation, but could I have just plug into the one where it says x equals 3y? That might have been a little bit easier, right? Because it says what x equals to. So why not plug in 4 there and you get the answer right away, which is 12. But you know, either way, right? This time I just plug into one of the original equation to show you that it doesn't matter. I still get 12. So what is the how do I write our solution now, Michael? What should I write?
You should write 12, 4.
12, 4 is correct. Very good. 12, 4. How come it's not 4, 12? Because I bet a lot of you wrote that. Camila, how come I cannot write 4, 12? Yeah, 4 is y. Why do you think, because I see this many times on the test, especially when you don't have much time to finish and stuff. Why do you think people write 4, 12 instead of 12, 4?
They rush.
They solve the one first.
Bella? Well, they think maybe they have to write the small number first. Yeah, that's one of the reasons. Another reason is because, yeah. What do you mean by that? Yeah.
They solved
Yeah, because they saw y first, they see y first, right? So they see 4 first, they just write 4, 12. Okay, please don't do that on the test, okay? You do all this work, if you switch that around, then your answer is not correct. Does that make sense? It's an order pair. Order pair means it's in alphabetical order, right? So whatever comes first in alphabetical order comes first. Is this easy? Do you like this method? Yeah. Okay, so here we go. Let's try some more. Here we go. Oh, by the way, if I wanted to check the answer, is it good enough to check 12, 4, plug that into only one of the equation? How many people think that it's okay to just check if you wanted to see whether or not you have the right answer, right? Could I plug in 12 comma 4 to the first equation only? Why not? What do you have to do then if you want to check the answer for sure? Yeah, you need to plug into both because we're solving systems, right? So this order pair must be solution for both, okay? Because one line, how many solutions does one line have? Infinitely many, because it's made right. Any point on that line is a solution. So it doesn't, you don't know whether or not that order pair you found, right, is solution for both, right? If you just plug into one of them, you got to plug into both of them. So when you have a chance, like on the test, this is what I wrote down. If you have time during test, check the answer by plugging into both of the original equations, okay? So that's what you should do. Here we go. Let's look at the next one. Example 3 says y equals to 4x minus 5. And then the other equation is 8x minus 2y equals to 20. Go ahead and solve. Now, I like this one because, look, why is this one nice?
Oh, it's already
Yeah, on the left side, it's already solved for y, right? Okay, very good. Go ahead, everybody then. Then there's nothing to think about, right? In terms of which one you should solve for and so forth. Go ahead, everybody try. I'll wait. This one might be a little bit different than the other ones, but let's see if you could do this one. Go ahead, everybody try. Let's take a look at this problem. This is kind of interesting. Did you all plug y in place where the y is on the second one? Yes. So did you all get 8x minus 2 times in parentheses? How many people use parentheses? Okay, please do, because if you don't, you may make silly mistakes. 4x minus 5 equals 20. Now, what do I distribute? Negative 2 or 2? Negative 2, right? So I get 8x, negative 2 times 4x, which is negative 8x. What's negative 2 times negative 5? Positive 10. That's what you should have gotten, right? And of course, what's 8x minus 8x? 0. So we get 10 equals to 20.
What?
Isn't that what we get?
I got 0 equals to 0.
If you solve for the second equation,
Okay, so you shouldn't have gotten 0 equals to 0. But Claire, do you follow me? After this, how did you get 0 equals to 0?
I magically discovered that negative 2 times negative 5 is 20.
Ah, okay. Yeah, negative 2 times negative 5 is positive 10. So you get 10 equals to 20. And now, as you can see, could I divide both sides by 10?
No.
Yeah, you can. If I divide both sides by 10, what do I get? No, 1 equals to 2, right? By the way, what does 1 equal to? 1. It doesn't equal to 2. What does 10 equal to?
10.
Yeah, it doesn't equal to 20, does it? So what does this mean? There is no solution. In other words, look at these two. Look at these two equations. If you were to graph these two equations, since we got no solution, what does that mean? The two lines are parallel. Is exactly right. So when you get a false statement, this means that two lines are parallel. That means there's no solution. Now, is there a way to verify whether or not these are parallel lines? What could we do? How about Jason? What could I do here?
Oh, you can solve put the other equation in slope-intercept.
Yeah, you could write this in slope-intercept form because I know this one has a slope of what? 4. And the y-intercept of 5. This line, let's solve for y. Let's just verify. If I were to solve for y, I get, let's subtract both sides by 8x. I get negative 2y, what? Equals to what? And negative 8x plus 20. Divide both sides by negative 2y equals 2. 4, negative over negative is positive, right? 4x plus what? Negative 10. So what's the slope of this line? 4. What's the slope? Y-intercept of the other line? And look at the slopes. The slopes are same, different y-intercept. What does that mean? Two lines are parallel. Does that make sense? So that's what we get there. Any question? You understand? Okay. So let's move on to the next one. Here we go. Here we go. Example 4. It says 2x minus y equals to 1 and 3y plus 3 equals to 6x. Go ahead and solve this system. By the way, which variable should you solve for? Or which equation would you like to use to solve for one of the variables?
Number 2.
Really? You want to use number 2 to solve for one of the variables? Because then you have to divide both sides by 3 or 6. You get fractions. I will use the first equation and solve for which variable? Y. Isn't that easiest? Okay, go ahead, everybody try. It doesn't really matter, but I think that's the easiest. You'll get the same answer anyway. Go ahead, everybody try. When you solve for y, what do we get on the left side? How about Eunice? I mean, not left side. The equation on the left.
Y equals 2x minus 1.
Yeah, y equals, so you add y to both sides, subtract 1. Y equals 2x minus 1. Isn't that right?
Yep.
Let's plug it in. Song, tell me what to plug it in. On the right side, what do I get?
3
Uh-huh.
2x minus 1
Good.
plus 3 equals 6x.
You got it. Okay, it's very good. So that's the third equation. We like this third equation because, of course, you got to distribute this, but we like this third equation because, look at this equation. How many variables do we have? Only one. We know how to solve this, don't we? So distribute this. We get 6x minus 3 plus 3 equals 6x. Isn't that interesting? We get 6x equals to 6x. Divide both sides by 6 if you wanted to. X equals to x. Now, what does that mean? The left side would always equal to the right side, right?
Yeah.
So what does that mean?
The lines are the same.
Angel? There are infinitely many solutions, which means, Matthew, the two lines are? They're the same line. They're the same line. The book uses the word, they coincide, right? Basically means they're right on top of each other, right? They coincide. So there are infinitely many. And again, if you wanted, I could rewrite this equation. Let's do that now. Let's write this. Okay, let's write this in slope-intercept form and see if they're the same line. Okay, what would you do that? How would you do this? Well, you first subtract. So you got 3y. Subtract 3 from both sides. 6x what? Minus 3, right? Divide both sides by 3. You get y equals to what? 2x minus 1. Look it. They're the same line, aren't they? Aren't they the same lines? Does that make sense? Why we get infinitely many solutions? Again, infinitely many solutions. Does that mean any order pair will work?
No.
No. Which order pairs will work?
Any on the line.
Yeah, any order pairs that's on this line. Does that make sense? Can you do something like this for your homework tonight? Is this pretty straightforward? Okay. Okay, very good, very good.